short. So let's get to it. Well, actually, the lesson's going to be long, but the homework's going to be short. Okay, lesson's going to be long. Homework is going to be short. All right, here we go. We're going to talk about series, arithmetic and geometric series. What's an arithmetic series? We found out, like yesterday, sequence is if you have a 2, 4, 6, 8, so on and so forth. That's an arithmetic sequence because you're adding 2 each time to get the next one, or subtracting 2 would be fine too. There'll still be, let's say you had 2, 0, negative 2, negative 4, so on and so forth. So you're subtracting 2 here. Okay. What's the difference between a sequence and series then? So if you just had 2 plus 4 plus 6 plus 8 plus 10 plus 12, so on and so forth, okay, this is known as a series. This is a sequence and this is a series. Okay, the only difference is we add up all the terms. Okay, so what if you wanted to add up like this is the first one, and this is the second one, and this is third one, so on and so forth, and let's say we want to go all the way to, we want to add up the first 100 terms. Well, we can't just keep going forever and ever. Add them up, you can do that, but we need a formula, an explicit formula. Or what if it was 1,000 terms, or 10,000 terms, or 100,000, or 1,000,000 terms? Okay, if we had a formula, we could add that up rather quickly. So that's what we're going to do today. Come up with a formula for arithmetic sequence. So I am going to prove it to you. Okay. Alright, let's start. Okay, arithmetic sequence. So let's say what you have is you have a first term plus second term plus third term, a sub 3, and this is called a sub 4 plus dot 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 dot. We're going to add up n number of terms. From yesterday, we found out that's my first term, but this one can be written as a sub 1 plus n minus 1 difference, or I'm getting ahead of myself, so that would be a sub 1 plus a difference. That's what that term is. And of course, this term is going to be a sub 1 plus 2 differences, and then this one will be a sub 1 plus 3 differences, plus dot 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 dot, and then the last term can be represented using a sub 1 plus n minus 1 difference. Okay, now we'll call this the sum. We'll use S for the sum. We're adding up n number of terms, and we'll get this as a formula. Now we have to come up with, well, we just can't keep doing that, so there's a way to condense this. So if we take S sub n again and we write this whole thing backwards, okay, this one goes to the front. You still will be the same, doesn't matter if you write forward or backwards. So you're going to have a sub 1 plus n minus 1 difference, okay, and then the one before that here would be a sub 1 plus n minus 2 difference, and then the one before that would be a sub 1 plus n minus 3 difference, plus dot 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 dot, and then very first one is going to be just a sub 1. So all I did was rewrote everything backwards. Now I can add up each column. Okay. So if I add up my left hand column, I'm going to have 2 s sub n's. Okay. Now notice when I add this and this, I'm going to get a sub 1 and an a sub 1, which is 2a sub 1 plus a n minus 1 difference. And then when I add up this and this, I'm still going to get 2 ace of 1s. So I'm going to have plus 2 ace of 1. But this difference plus n minus 2 will make that into another n minus 1 difference. Okay. And then when I add up this and this term, the third terms, I'm going to get plus, I'm still going to have 2 ace of 1s. Okay. And then, oops, let me write 2. Okay, 2 ace of 1s. 2 ace of 1 plus the n minus 3 difference plus 2 difference will make that into n minus 1 difference plus dot 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 dot. Okay, and then the very last one, when I add that up, I'm going to get exactly the same thing again. I'm going to get 2 ace of 1s because of ace of 1 here and ace of 1 there, and n minus 1 difference. So n minus 1 difference. Well, how many of these do I have? I don't have 4 because of dot dot dot. I have n number. And I'm adding up n number of terms. So I'm going to get 2 s sub n is equal to n times 2 times a sub 1 plus n minus 1 difference. Okay. And then we're going to divide by 2, so s sub n is n over 2, all that times 2 times a sub 1 plus n minus 1 difference. And there it is. That's our magic formula. This is the magic formula. Now, there's a second formula that goes with this, because I can split this up as n over 2, a sub 1 plus a sub 1 because I have 2 of these, and then I have a plus n minus 1 difference. Now if you really look at this, this is really my a sub n, because that's the formula we learned yesterday. So I can rewrite this as n over 2, all that times a sub 1 plus a sub n, meaning first term and the last term. Okay, a sub 1 is the first term and a sub n is the last term. So in a nutshell, let's rewrite this formula, clear this out. So my sum formulas is going to be n over 2, all that times 2 a sub 1 plus n minus 1 difference, and or you can use this as n over 2, all that times a sub 1 plus a sub n, which is the first and the last term. Well, it all depends on if you're given the d. If you're given the difference, you can use this formula. But if you're just given the first and the last term, you can use this formula. Okay? So this is formula for adding up arithmetic series. Okay? So let's go ahead. This is the arithmetic series. Okay, let's do some problems, and then we'll get to geometric series. Okay, let's clear that out. Let's get to 25. Well, this is k is equal to 1 to 15. Okay, this is known as a summation notation. Okay, and it's saying 11 minus 2k is my formula. What this really means is, if you do it the long way, is they want you to, in this formula, they want you to plug in 1 for k, so it would be 11 minus 2 times 1, okay, and then add to that 11 minus 2 times 2, and then add to that, okay, 11 minus 2 times 3, and then add to that 11 minus 2 times 4, and then add to that 11 minus 2 times 5, so on and so forth. They want you to keep on doing that until you get the very last term, 11 minus 2 times 15, okay, and they want you to add them all up, okay. So this is your start, and then and work out each one of these. Of course, it's going to take some time, so let's see if there's a pattern to this. Okay, so the first one is 11 minus 2, which is going to give me 9, plus next one's going to be 11 minus 4, which is going to give me 7, and the next one's going to be 11 minus 6, which is going to give me 5. Looks like it's going down by 1, so if you keep going down, you're going to get next one's going to be 3, and the next one's going to be 1, and then the next one's going to be negative 1, and the next one's going to be negative 3, and then the next one's going to be negative 5, so on and so forth, until the very last one, which is going to be 11 minus 30, and that's going to give us plus negative 19. Okay, so we can do all that and get the right answer for this, or once you know your first term, that's your a sub 1, and then we know a difference. My difference is 2 going down, so it'll be negative 2. And then we also know what my n is. N happens to be 15 because I'm adding up 15 terms right there. So my sum I can find my s sub 15 using my formula n over 2, okay, all that times 2 times a sub 1 plus n minus 1 times difference, which is really 15 over 2, all that times 2 times 9, okay, plus 15 minus 1 times a negative 2. Okay, so if we clean this up, this now becomes 15 over 2, all that times 18, because 2 times 9 is 18, and then negative 14, or positive 14 times negative 2, which is negative 28. And that reduces to 15 over 2 times negative 10, and they reduce to negative 5, so 5 times 5 is 25, and then 2 times 5 is 5, so negative 75 is the answer, if you add them all up. So, once you get a couple of these, you can use this formula, or you can use the second formula, because we know what my first term is, and we know what my last term is. So let's use that formula too. So see if we get the same answer. S sub n is equal to n over 2, all that times the first term plus the last term. So my s sub 15 will be 15 over 2, all that times 9, plus a negative 19. Okay, and that's going to give me 15 over 2, all that times negative 10, and then that reduces to negative 5, which will give you negative 75. Okay, so it's probably easy to just go to the first and the last term, okay, when you have something like this, and then you can find the sum of all the terms. Okay, that's arithmetic series, and we have one more thing in arithmetic series, so let me show you that. So number 28, okay, and that is 8 plus 10 plus 12 plus 14, okay, and then they want dot 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 dot, n is equal to 15. Okay, but they don't give you the last term, so you have no choice to add up the first 15 terms. That's first, second, third, fourth. You can keep going if you see a pattern if it's going up by 2. So we can just use the formula. So s sub 15 is what we're trying to find. Okay, and my a sub 1 is 8. My difference is plus 2, and my n is 15. So my formula will be 15 over 2, all that times 2 times a sub 1, which is 8, okay, plus n minus 1, which is 15 minus 1, times the difference, which is 2. Okay, let's clean this up. 15 over 2 times, I have a 16 here, okay, plus 14 times 2, which is 28. Okay, so we're going to add 14, 16, and 28. So when I add 16 plus 28, I'm going to end up getting 44. So that's 15 over 2, okay, times 44. Of course, 2 and 44 reduce, I get 22. So when I take 22 and I multiply that by 15, it turns out to be 330. And that's the sum, okay, of an arithmetic series. Let's find sum of a geometric series. Okay, I can also prove this formula, but for the sake of time, since you're probably bored right now, okay, if I prove it, and I'm just going to save us some time and just give you a formula for sum plus 4 plus 8 plus 16 plus 32 plus dot 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 dot. That's a geometric series. Okay, it's because we're multiplying everything by 2. Okay, to get the next one. So we can also multiply my rate, and the ratio here is called 2, because if you multiply everything by 2, that's called a ratio. So we can also have ratios equal to negative 2. So if we still start out with 2, okay, multiply by negative 2, you're going to get minus 4. Multiply by negative 2, you're going to get plus 8. Multiply by negative 2, you're going to get negative 16. Okay, and then plus dot 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 dot. Now here my ratio is negative 2. It can also be, ratio can also be 1/2. Let's say we start with 10 and we multiply by 1/2. That's going to give me plus 5. Multiply that by 1/2. That's going to give me 5 over 2. Multiply this by 1/2. It's going to give me 5 over 4. So on and so forth. My ratio can be a fraction also. But I'm multiplying by a number to get the next term. Okay, I'm adding all the terms up, so that's called a geometric series. Instead of proving the the formula for a geometric series, I'm just going to give it to you. My formula is S sub n is equal to a sub 1 times 1 minus r to the n, all that over 1 minus r. Okay, this is the formula for geometric series. So if we want to add a few of these up, okay, any one of these, okay, we have to use this formula. Alright, so let's go ahead and use this formula and do a few of these problems. Let's start with 31. Okay, 31, they give us k is equal to, in a summation notation, k is equal to 1 to 7. Okay, and then they want to go negative 3 to the k minus 1. So remember, I told you this is always the start, and this is the end. In this situation, k is where we're going to start. So the first term is going to be negative 3 to the 1 minus 1, because my k starts out with 1. And the next term is going to be negative 3. Okay, it'll be 2 minus 1. Okay, and then plus a negative 3, 3 minus 1. And so on and so forth, all the way until you get to where you have a negative 3 to the 7 minus 1, because that's my ending point right there. And if we clean this up, okay, this right here is equal to that. So I'm going to get a negative 3 to the 0, plus I'm going to get a negative 3 to the 1, plus I'm going to get negative 3 to the second, plus dot 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 dot, plus negative 3 to the sixth. To clean this up some more, anything to the 0 is 1. Okay, negative 3 to the 1 is negative 3, negative 3 to the second is positive 9, so on and so forth, and all the way to negative 3 to the sixth. Okay, so negative 3 to the sixth, let's do that. Let's see, find out what that is. So 3 to the sixth, that turns out to be positive, okay, 729, because we're going to add all these up. Well, that's a long way of doing it. Since we have a formula, S sub n is equal to a sub 1 times 1 minus r to the n, all that over 1 minus r. Since I'm adding 7 terms, I'll call this S sub 7 is equal to a sub 1. We do have to find the first term, which is my 1. Okay, and then 1 minus r. And what's the ratio Well, the ratio is you take any number divided by the previous one. So 3, negative 3 over 1 is negative 3. 9 divided by negative 3 is negative 3. But it's also given to you right there. There's my ratio. Okay, negative 3. So it's negative 3. And then we're going to raise that to the 7th power. All that over, okay, 1 minus ratio, which is negative 3. Okay, let's clean this up. I have a 1 times 1. I have a negative 3 raised to the 7th power. Okay, so that's going to give me a negative minus a negative 2,187. And all that's going to be over negative. 2 negatives here will become positive, which is a 4. Of course, these 2 negatives will become positive also. So I have 2,188 times 1, which is 1, all that over 4. So 2,188, and we're going to divide that by 4. Okay, that turns out to be 547, and that's our answer. Okay, so we can just use the formula to find the answer. Let's do a couple more of these. Okay, and we can stop there. So let's look at 35. Okay, 35, I have a negative 4, negative 8, negative 16, okay, negative 32, and they said dot 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 dot. I'm going to add them all up, and it's equal to 8. Okay, we know my a sub 1, which is negative 4. My ratio is any number divided by the previous one, so negative 8 divided by negative 4, which is going to give me 2. Okay, and my n, they give me that, so here's the formula. S sub 8 is equal to first term, which is negative 4, times 1 minus the ratio, which is 2, raised to the 8th power, that's my n, all that over 1 minus 2. Okay, so we're going to raise 2 to the 8th power, okay, and then we'll get that first, which is 256, so the negative 4 times 1 minus 256, okay, all that over negative 1. Alright, so the 2 negatives here will cancel off, and then I have a 4 times negative 255 inside the parentheses, so 255 times 4, and it's negative, so I'm going to get a negative 1020. Okay, so I want to do one more, which is 37, so let's go ahead and take care of that, and then we'll be done. So 37. 37, I have a sub 1 is equal to 1, and my ratio is equal to 4, and then they tell me S sub n is equal to 341, and they want me to find the n. Okay, find n. So how many terms does it take? If my first term is 4, my ratios, if I'm multiplying each one by 4, and I add them all up, okay, and then I get 341 as my total. So how many terms does it take to get that? Okay, so if you want to expand this, it will look like this: 1, then plus 4, then plus 16, plus 64, plus dot 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 dot. So you can work it out the long way, or we can also use the formula S sub n. This is known as the explicit formula. S sub n is equal to a sub 1 times 1 minus r to the n, all that over 1 minus r. So we know this, that's 341. Okay, we know a sub 1, which is 1. Okay, and then I have a 1 minus r. The r is given to me, which is 4. And I don't know what the n is, so I have that, all that over 1 minus r, which is 4. Okay, so I have a 341 is equal to, okay, 1 minus 4 to the n, 4 to the n, all that over negative 3. Okay, so I'm going to multiply 341 by negative 3, so 341 times negative 3 is going to give me negative 1023, which is equal to 1 minus 4 to the n. Okay, I'm going to take the 1 over to the other side, becomes negative, so I get negative 1024 is equal to negative 4 to the n. I'm going to divide both sides by negative. Okay, so I'm going to get 4 to the n is equal to 1024. Okay, now I'm in this situation where I have to solve for n. The n is in the exponent, so I'm going to have to ln both sides. So ln of 4 to the n is equal to ln of 1024. That's the only way I can solve for that, because I have to ln. Okay, so that, using the logarithms, okay, I can bring my n to the front. I get ln of 4 is equal to ln of 1024. So my n is equal to ln of 1024 divided by ln of 4. So we'll go to calculator, and we're going to find ln. Okay, so ln of 1024. Okay, and then we're going to divide that by ln. Okay, I'm punching my handy dandy calculator here. 4. Okay, I'm going to hit enter, and miraculously that turns out to be 5. Okay, so if you get the next term here, okay, which is 4 times 64, okay, so 64 times 4, which is 256, so 256, when you add them all up, that turns out to be 341. Okay, of course you're going to say, well, why would you want to go through all of this, okay, when you can just do it the long way? Okay, that's true, okay, but that's only because we're adding up first 5 terms. What if we're adding up first 1,000 terms? Okay, so you won't be able to do that. Alright, okay, that's it.